All right. The other bundles that is important in physics is the cotangent bundle, and it has to do with how the Hamiltonian formulation of classical physics is formulated. So we start with the let M be the smooth manifold again. Okay. So again, the cotangent space. So I'm gonna switch label here. Instead of using P for the point of M, element of M, I'm gonna use X as an element of M because I will reserve the P to represent the conjugate momentum to the velocity variables in the Lagrangian formulations. Okay, and so the cotangent bundle is defined to be the union or the collection of all the tangent spaces at X, all the point X in M. So if you have that whole collection, that means you have the tangent bundle. Okay, so here's a visual of that. Again, M here is just represented by just one dimensional, but it can be higher than just one dimensions. And then that U alpha containing the point X. And of course, if you go straight up from, I'll just give the surjective math first. Okay, so sigma. Let's use a different letter. Let's use tau. Let's say. Okay, tau. Tau is a projection similar to the pi projection for the tangent bundle. Okay. And then, of course, if you project X all the way up onto the tangent bundle, pick a point P. So that would be your momentum or the point on the cotangent bundle. And so the way you write that is, here's a projection, canonical projection or surjective function on the tangent bundle here. I just map everything to M. So P get mapped to tau of P, which is equal to X. Okay. Okay, so now if I inverse tau or inverse projection of tau here of this open set U of alpha, then pi to the -1 of U alpha would be this portion. Okay, and then that straight line containing P would be the tangent space of the cotangent space of at the point X. Okay. So the domain of tau -1 of U alpha is a subset of the cotangent space. Now at the manifold level, again we have similar things. We have chart that can map that into Rn. Yeah, not M. It's U of alpha subset of the manifold into phi of U of alpha, which is a subset of Rn. Okay. And of course, phi of alpha of X by itself is an n-tubal, X1 all the way up to Xn. Then if you have another open set containing x, let's say u of alpha, u of beta. Okay, so this chart here, phi of alpha, will induces a chart on the tangent bundle. So let's just put a label hat. So whenever you see the hat, it just means that it's referred to the cotangent bundle in this case. So if you take the inverse tau of the u of alpha, then you get the domain of the cotangent bundle. So I'm define that as again with the u of alpha with the hat on it is going to be inverse tau of u of alpha. Okay. So phi of hat is a mapping of the domain that we just specify, the subset of the tangent space of the cotangent bundle into the R to the 2n tuple. Okay. Okay, so now if we let so if we let P as an element of the cotangent space, so notice P is equal to Pi lowercase I times dxi uppercase. So this object here is a covector because the dxi is a one form. Okay. Now let's take a look at the coordinate transformations on M first. Okay. So xi here get mapped to xi prime, but it's a function of the O coordinates. Okay, so this is just a transition map at the manifold level M. Okay, because of this transition map down here, it induces a transition map or coordinate transformation on the cotangent bundle. Okay, so and here's how we define it. The cotangent bundle, you have x here is the point on M, and then pi here is the momentum or the conjugate variables to the velocity in this cotangent space. It get mapped to this. So the first one, so at the manifold level, you get xi go to xi prime, and then the momentum get mapped to pi prime. Okay. And the way the transformation goes is since the indice is downstairs, the pi here transformed like the basis for the regular vector. Okay. If you remember in relativity, this is how the basis get transformed. Okay. So it's like the inverse Jacobian to the one on the tangent bundle. Okay. Okay, again, and together, if you have a collections of open sets U alpha hat and phi alpha hat, then we have an atlas for the cotangent bundles.